This video will show you how to perform a simple linear regression in R. To do this, we're going to use the iris dataset. I've loaded the iris dataset. I'm going to click on the spreadsheet looking tool to see how it looks. And yeah, I have sepal length, sepal width, petal length, and petal width, along with the species as variables that are part of this dataset. So it looks like I have the data loaded in correctly. So now I'm asked to perform a simple linear regression that predicts sepal length using petal width. And so in this case, sepal length will be our response variable and petal width will be our independent variable. So the first step of doing a simple linear regression is to name your regression something. And so in this case, we will name it and store it as an R object. So I'm going to do iris.reg is what I'm going to call my R object that stores this simple linear regression. That way we'll be able to look at the output in the future. So iris.reg, and then the function we use for simple linear regression is LM. And so LM stands for linear model, and that's one of the most common functions in R to perform regression. So we're going to do LM. The first argument in the LM function is the response variable, or in our case, sepal length. And then we're going to say sepal length is a function of, and to say is a function of, we'll use a tilde. Sepal length is a function of petal width. And so in this case, sepal length is the response variable, petal width is the explanatory variable. And then the last thing we'll need to do is put a comma and say our data set that we're going to use is the iris data. And so I could run this right now, and let me do that for you. So I run it, and you can see it looked like it ran something, but we're not seeing any output. And so to see some output on the next line, I'm going to type summary of iris.reg. So now I'm going to hit the play button to run that chunk. And you can see I've got lots and lots of output from my simple linear regression. So the first thing it says is it's the call. So it types, just kind of respits out the formula. Sepal length is a function of petal width using the iris dataset. And then we have the residuals. So here's the distribution of residuals, the minimum, first quartile, median, third quartile, and maximum value. Now, perhaps most of interest to us are the coefficients. And so thinking back to what the simple linear regression equation looks like, our intercept is often represented by beta 0, and our petal.width is our slope, or represented by beta 1. And so the values for those, the intercept is about 4.77. The value for the slope is 0.888. And we have some other values associated with it, the standard error, t-value, and p-value. And so I can scroll down too. It lets me know how significant each of those variables are, which we'll talk more about later in this class. And then it tells me some other things in the output here. So it also tells me the R-squared value of 0.669. So this would indicate about 67% of the variability in the sepal length is explained by this regression line. So some important information that we might be interested in. So I next want to know what is the predicted sepal length for an iris flower with a petal width of 1.2 meters. And so in this case, we can use the coefficients that were found for our example and write some R code to predict the sepal length for a flower that has a petal width of 1.2 centimeters. And so to do this, we're going to use the equation beta 0 plus beta 1 times x is equal to our y value. In this case, is equal to sepal length. So here, I'm just going to look at my R output and type those values that I see into my R code. So in this case, the intercept is 4.77763, and I'm going to add 0.88858, and then I'm going to multiply by 1.2, because I'm interested in knowing what the sepal length is for a flower with a petal width of 1.2 centimeters. And so I've basically written out my simple linear regression, and now I can tell you what my equation thinks the sepal length should be for a flower with a petal width of 1.2 centimeters. So I hit the run button to run the current chunk. And in this case, the values for sepal length are in centimeters as well. So our equation, our simple linear regression, would predict a sepal length of 5.84 centimeters if a flower had a petal width of 1.2 centimeters. So that's how we can use and perform a simple linear regression in R.